Sorry, everybody, technical difficulty, but we're back now. Okay, so using the segment addition postulate, we're going to move on and try to solve a couple of problems. And these are really typical problems that you see at the beginning of a year in a geometry course. So we've got a diagram right here, and what we have is a line segment here in black with 3 points that are kind of identified here, and we're going to try to find x, although I really shouldn't have written find, and I should have had solve for x, which is really what we're doing. And this is the type of problem that a lot of students are going to look at and just say immediately, ooh, I know the answer, and they're going to be right. But I'm going to ask you guys to slow down just a little bit, because in a moment, we're going to look at a more complicated problem, and then a really complicated problem after that. And some of us who have good intuition, who can solve problems like this just by looking at it, then we run into trouble when it gets a little bit less obvious. So what I'm going to try to remind you guys here is the segment addition postulate that we just learned a moment ago that says little segment plus little segment is equal to big segment, or something like this. So in this context right here, trying to do little segment plus little segment equals big segment, our first little segment is right here, and it has a length of 11. So I'm going to write that down. Then we're going to add to that the length of the second little segment, which is right here, and that's going to be x. And little segment plus little segment is equal to the length of the overall segment, which we have right here is 17. And what we just did, everybody, for the first time in our 3 sections of notes here thus far, is something we are going to do a ton of throughout the year. Translating a known statement that is true, whether it's a postulate or a theorem, into a mathematical equation. And that's what we did. We used the segment addition postulate to write our equation out, and now from here we use algebra simply to solve that equation. Where's my variable? Right there. What's happening to it? They're adding 11 to it. And how do we undo the addition of 11? We subtract 11 from the left, but of course we do the same thing on the right as well. Those 11s cancel each other out, and we just end up with x equals, and here we go, guys, we simplify our right side, 17 minus 11 is 6. And then, when I fixed my directions and they actually say solve for x, that's when we know we're done. When you've got variable equals a constant, a number all by itself, fully simplified, that's when you know you're done solving an equation. Okay, so that's how we do it. Some of you are probably annoyed with the fact that I took the time to write an equation out there instead of just looking at it and saying, oh, obviously the answer is 6. But I think you might see why when we get to the harder problems starting right here. Same setup now, guys. We've got this long black line segment right here with another point in the middle, and there's actually 3 line segments here. 2 little ones, and then the big one. So say it with me again, guys. The segment addition postulate, little segment plus little segment is equal to the big segment. Our first little segment is right here. It has a measure of 3x. And we add to that now the length of the second little segment right here, which is a binomial expression of 7x minus 4. So that's little segment plus little segment equals, and the entire figure here has a length of 26. All right, so that's the setup, guys. And when we take tests and quizzes with a problem like this, if you guys can just set up the correct equation, that's going to be worth at least half the points on a problem like this. Very often, a problem like this on a quiz or a test will be worth 3 points. And if you can get this equation right here, you're going to get 2 of those 3 points. That's more than half. Now the algebra kicks in. And the one thing I'm hoping you guys notice right here, we've got 2 like terms on the same side. Now, what I see a lot of people do wrong is something like this. So please don't write this in your notes. I'll see some people try to do a minus 3x here and a minus 3x here. The mistake they're making is that they're subtracting 3x twice on the same side of the equal sign. Some of your Algebra 1 teachers taught you to draw a line right down the middle here from the equation. And if you're going to subtract 3x on the left side of the equation, you would need to do it over here on the right side. So what I have drawn right now, while not really helpful, is at least technically correct. But more to the point, what I forgot here, guys, is that if you've got these two x terms on the same side, what we need to do right here is CLT. And that means combine like terms. 3x and 7x combine because they're on the same side to make a 10x. Everything else stays exactly the same. Minus 4 equals 26. Now there's no more like terms to combine, so now we start moving things around. How do we get rid of a minus 4? We add 4, once on the left of the equation and once on the right side of the equation. Those cancel out, and we now have a 10x is equal to 26 plus 4 is going to be 30. And how do we get rid of multiplication by 10? We're going to divide by 10 on both sides. And we're going to get our answer now of x equals, and 30 divided by 10 is 3. Now is a good opportunity to go back and talk about something that I know your Algebra 1 teachers taught you and most of you guys completely ignored. The best thing about solving equations in algebra, and it works really well in geometry here too, is that you can always check your answer by plugging it back in. So we think we know, we're not sure, but we think we know that x is 3. So how long does that make this segment? 3 times 3 would give us a length of 9 right here for that segment. How about moving on to the right here? 7x. So 7 times 3 is going to be 21. You guys could use your calculator here if you need to. And 21 minus 4 is going to get us 17. And now, if we take a look at the two small segments, little segment plus little segment, 9 plus 17 should equal the measure of the big segment right here. And sure enough, guys, 17 plus 9, let's do this old school. 7 and 9 is 16. Bring down the 6, carry the 1, 26. That is what the measure of our big outer segment should be. And you guys could use your calculator there if you need to, but that's a great habit to get into, especially in geometry now. You solve for x and you plug it back in and you make sure it works and it makes sense. Okay, third example I have for you is the most complicated of the three, because this equation is going to have x's all over the place. Little segment plus little segment is equal to big segment. Let's do it again. So our first little segment, dh, right here, is 4x minus 3. We'll add to that our second little segment, hs, which is 2x plus 5, and that has to equal the measure of the big segment right here, which is 8x minus 4. Now, once again, we've got like terms to combine. 4x and 2x on the left, but also constants. Remember, that's a negative 3 and a positive 5 there on the left. So 4x and 2x combine to make a 6x. Negative 3 plus 5 make a positive 2, and that equals 8x minus 4. Now this one's a little more challenging than the last ones because we have variable terms on both sides. We also have constant terms on both sides. And I would like for you guys to push yourselves maybe a little bit harder than you did last year in Algebra 1. I think you guys can handle doing two things at once now. If you take a look at your x terms, we have a 6x on the left, an 8x on the right. We always want to move the smaller term to the bigger one. 6x is my smaller term, so to move 6x, we're going to subtract a 6x from the left and subtract it from the right at the same time. However, since all of our x's are now moving over here to the right, that means I'd like to move all of our constants over to the opposite side, which in this case is the left. So I'm going to move that negative 4 over here to the left side. And how do I do that? I get rid of a negative 4, a minus 4, by adding 4. Once on the right, and I'll balance that by doing the exact same thing on the left. And what I want you guys to notice is, even though I'm doing two things at once, I'm doing the exact same thing on both sides of the equation, subtracting 6x and adding 4. Okay, so what cancels here? This 6x minus 6x, gone. This minus 4 plus 4, gone. And where does that leave us? The 2 plus 4 is going to be a 6, and that equals 8x minus 6x, which is going to give us 2x. We'll divide both sides by 2 now, and even though this is backwards, we don't really care. We're going to end up with our answer here, at least we think, of x equals 3. So I'm going to box that up right now. Now I know this looks like a big pain in the neck when I ask you 4 different questions, but it's actually doing you guys a favor right here because it's encouraging you. In fact, it's requiring you to check your answer. So let's see what we have. We believe that x is equal to 3. Let's see what that does for our individual segment measures. Again, we read this right here as the measure of segment DH. So here we go. DH is 4x minus 3. So 4 times an x value of 3 is 12. 12 minus 3 is going to get us 9 for the measure of DH. How about HS over here? That's going to be 2 times 3, which is 6, and 6 plus 5 is 11. Now again, some people are going to stop me and say, whoa, 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 that can't be right because HS, I can see right here, is shorter than DH, but here you're telling me that it's bigger. Remember, guys, we don't trust our eyes. We trust the numbers. You cannot look at a diagram and know for a fact that one segment is longer than another. Okay, and then let's finish this thing up here, guys. Oop, needed that. Let's check DS right here. If x is 3, 8 times 3 is going to be 24, and 24 minus 4 is going to be 20. And now ask yourself, do these 3 answers make sense relative to one another? Yes, they do, and I think you guys can see it. 9 plus 11 is going to equal 20. So that doesn't guarantee that we got this problem right, but it makes me feel really, really like 99% confident that we're doing this one correctly. Okay, couple quick things to talk about before we're done with section 1.3. The next thing is a vocabulary term, congruent segments. And congruent is a vocabulary term that we're going to use a lot in geometry. And what congruent means is having equal measures. Basically, you're saying that 2 things are the same. So the word congruent and the word equal are really, really similar to each other, guys. The difference being equal applies to numbers and numerical quantities. 2 plus 3 is equal to 5 because we're talking about numbers. Congruent is when we talk about geometric figures. So I'm going to try to eyeball this right here. If I was going to draw one line segment right here, let me call this point A and this point over here B, there's one line segment. And as carefully as I can here, guys, no guarantee at all, I'm going to put a point C right over here, and I'm going to try to go a distance that's the same distance, there we go, and I'm going to call that point D. And my hope would be, I'm not sure how I did there, that I drew 2 line segments that had the exact same length. If the length of AB was 7.8 centimeters, then I would want the length of DC to be 7.8 centimeters as well. The notation for segments being congruent, there's a symbol for it. Here's what we would write. Line segment AB. So I put the segment symbol over the top now because I'm naming a geometric figure, is congruent to. So what we do for congruent is we draw an equal sign, but then this little Spanish tilde right over the top right there. Line segment AB is congruent to line segment CD. Now, the reason for that, guys, let's go back to what we just wrote down a second ago. The word congruent means having equal measures. So the reason these are true is because, and let's go back to the notation we used before, the measure of line segment AB is equal to the measure of line segment CD. So that's a little bit weird to get used to right there. We use the symbols here over the top and the congruent sign. But if we're not using the symbols, we're talking about numbers, then we use the equals. Now, another way we can indicate in a diagram that 2 segments are congruent without necessarily knowing how long they are is with something called tick marks. And a tick mark is just this little symbol that I make intersecting a line segment like that. And if I do the same number of tick marks over here on DC, that's our quick shorthand way of knowing that these 2 line segments are congruent, even if they don't necessarily look perfect. So 1 tick mark on AB and 1 tick mark on DC means that they have to be congruent to each other. If I were to put 2 tick marks on one, but only 1 on the other, we want to be careful how to read this. Now at this point, we would say these two line segments are not necessarily congruent. It still means that they could be. It just means that we don't have that much information yet. But if I go back and put a second tick mark on DC, now 2 tick marks here and 2 tick marks here, now I know that those segments are congruent again. So you can see that showing up in a couple of different ways. And let's do one last problem before we're done with section 1.3. We're going to solve for x again. And once more, I've given you a line segment with 3 points kind of located on there, even though there are more. One on the kind of the top, we'll call that point T. One in the middle here, I'll call that point U. And then we've got a point V down here on the bottom. Now, at first glance, this problem looks similar to one of the ones that we did here, or maybe this one here. And in those two problems, we used the segment addition postulate, which said little segment, 3x, plus little segment, 7x minus 4, is equal to big segment, 26. And here we did the same thing. Little segment plus little segment is equal to big segment. We've got a problem, though, if we try to do that here. Little segment, the first one, is 7x minus 3. And if we add to that the second little segment, which is a 4 times the quantity 2x minus 2, we're doing fine so far, guys. Little segment plus little segment equals, and now we run into a problem. What is the measure of line segment TV? They didn't give us anything here for the measurement of the entire thing the way they did here with the 8x minus 4 or here with the 26. So what are we supposed to do? It looks like at this point there's not enough information to solve this problem. Well, you're kind of right about that, but there is also, and this is usually a good question for you to ask yourselves, is there something in this problem right here that I haven't used yet that they did give me? And the key to that here, guys, and it's relative to what we were just talking about, the key to that are the tick marks here and here. The double tick mark on TU and the double tick mark on UV tells us that these two line segments are congruent. Line segment TU is congruent to line segment UV. How do I know that? It's not an assumption. The tick marks in the diagram tell me that. And what that means for two segments to be congruent is that the measure of segment TU has to be equal to the measure of segment UV. That means I can make a little change in this equation right over here, guys, and the measure of TU, which is 7x minus 3, must be equal to the measure of UV, which is 4 times the quantity of 2x minus 2. You don't need the length of the third big segment right there, guys. If they've given you tick marks, you know that you can set these two equal to each other. So let's solve that. First thing we're going to need to do here to simplify the right side, we're going to have to distribute that 4. Now the left side just goes along for the ride because it's already fully simplified. 4 times 2x is going to give us an 8x, and 4 times that negative 2 will be minus 8. Let me collect all my x's. The little guy moves to the big guy, so minus 7x on the left and the right. And if all of my variables are going right, I want all of my constants to go left. I get rid of the minus 8 by adding 8 on the right and on the left. So let's see. Those 7x's cancel. Those 8's cancel. And I think we got lucky on something here, guys. Negative 3 plus 8 is going to be 5. 8x minus 7x is 1x. We just write that as x. And because our coefficient is 1, we're done. We've got x is equal to 5. Let's check that real quick just to make sure that we got that one correct. If x is 5, here we go. 7 times 5 is 35. 35 minus 3 is 32 for the measure of TU. And how about over here for UV? 2 times 5 right there is going to get us 10. 10 minus 2 is going to be 8. And then we multiply that 8 times the 4 out in front. 8 times 4 is 32. And that works with the tick marks right here, which tell us that those two segments are congruent to each other. All right, guys, that's a wrap on everything we have on line segments in section 1.3. So let's give that homework a try. Good luck, everybody.